Well, welcome everyone. It's another Wednesday near a full moon, so we're not out anyways, and the weather is crappy. But this world record storm in North America. At least we're not living in Winnipeg. It's April 13th, 2022, and we have two great speakers. Our second speaker, Qual, will join us around 8:30. Our first speaker is someone you probably have heard of before, if not already know personally. Thank you very much, Blake, for joining us. This has been really exciting, and I'm all ready. I've even done my homework for his talk. I got my book. Blake Nancaro joined Rask in 2007 to determine if he should stay in the astronomy hobby or not. It's a shocking opening statement for a bio. That's good. He became a supervisor at the Carr Astronomical Observatory, and he's been its director for a couple of years. He's a trained operator for the 74-inch telescope at the David Dunlap Observatory, which is much bigger than my little 6-inch in my backyard. Now Blake is the chair of the National Observing Committee, and he's on the Observer's Handbook proofreading team. Oh, that's a lot of work. And regularly teaches courses on Stellarium software, which I'm sure we all know and love. And in the daylight hours, Blake is an instructor in information technology and regularly teaches business software applications such as Excel and Power BI, as well as presentation skills and project management. So I'd like to welcome Blake to talk about, I got my little slide here, or you got a slide. We're going to be talking about measuring double stars, techniques for amateur astronomers and citizen science. And I'm going to mute now. Thanks, Blake, very much for joining us.
Thank you for having me. Can you hear me okay? Is my shared screen coming through all right?
So, yes.
Thanks again for having me. I appreciate the introduction. I wanted to talk this evening about something that's very passionate for me. I feel very strongly about. And that is double stars and how important they are. I don't know why exactly, but I think there's not been some appropriate attention given. I was really impressed when I learned about Carl Jorgensen's efforts.
Restaurant or something like that, right? So get some exposure. Like me working at Foxborough, right? I didn't do engineering work.
Well, can you mute Terry, please?
All right. So I was saying that I was very impressed when I learned of Carl Jorgensen's efforts at increasing awareness about double stars, and I've been feeling the same way the last few years. I'm very impressed by his efforts at getting people looking at these particular targets, and I'm trying to do the same thing. And I want to encourage people to consider measuring them. If you want to do citizen science, you can. Hopefully my internet's not too wobbly here. As I transition to slides, my audio might break up, so I'll just sort of pause as I switch from one slide to another. If my audio goes really slow, let me know.
Yeah, it's a little bit shaky. It's a bit shaky. Yep.
Yeah, I've tried to minimize everything on this computer. So I started casually looking at double stars back in the 1900s. I actually came across articles on the Sky and Telescope website and in their magazines, and they have a couple of great lists. They have a winter double star list and a summer double star list, and I sort of took all those and I started viewing those doubles, and then I started adding to that list and really enjoyed viewing double stars. Around 2007, I got Sissy Hawes's book, which I was looking today. It looks like it's out of print. You can't find it anymore. And people that are selling it, it's like crazy, no pun intended, astronomical prices. I started getting interested in measuring double stars, and the late Jeff Garrity, that I think many of you know or knew, he gave me his Celestron micro guide eyepiece. So here it is here. So that's an astrometric eyepiece from Celestron, and it's got a little light emitter in it, and it's hard to see, but there's a reticule inside there. So I used that to learn how to measure double stars. I learned a couple of different methods. I created my own refined method. I built my spreadsheet so I could reduce data on the fly. And then I started exploring some other methods. I'm going to talk about in a moment some of the different methods that are available to us and that you could consider exploring. But all the while, I was starting to wonder why aren't people talking about double stars? There was very few articles in the journal, and yes, we have 2 lists in the Observer's Handbook, which is great, but people weren't talking about them at what's up this month presentations, and they weren't being included in sort of talks. And I would start showing them at star parties, and they were a big hit. People really like looking at those, and I saw that there was very little support broadly in RASC. And that's when I started to get really sort of committed to doing something about that. And I created the National Double Star Observing Program. So I was being sort of driven the same way that Carl was to do something about that. I have since observed over 1,700 pairs, or split 1,700 double stars. I've seen close to, or tried for close to 1,900. So there's a bunch that I have to go back at and look at again. So I'm getting pretty close to 2,000. And I love talking about these, obviously. Why do we want to look at double stars? Why might we include them in our observing campaigns? Why might you want to show them at star parties? Okay, I'm biased, but I think they're great. They're fun, they're colorful, they're interesting. They always evoke a lot of questions at star parties. They're low-hanging fruit, they're eye candy. People see color right away. If you show people a galaxy, they won't see color. So this is really fun that way. They're easy to sketch, pretty easy to sketch. If you can do dots on a piece of paper, you're good. And they're pretty easy to photograph compared to, say, deep sky objects. I'm really intrigued, Russell, you'll be happy to hear this, that I'm very intrigued at looking at what I call fast movers. These are binary systems that have periods less than 100 years. I have a short list with about 20, and I go back every year. I go back every season and look at them, and I'll do a sketch or I'll take a picture, and I'm looking at where that other star is moving. And we can see some of those move in the course of our lifespan. Don't look at binary systems that have 4,000 year periods, because you won't see any motion there. But there's lots that are sort of within our grasp. I casually measure double stars every time I look at them, but we can measure them formally, and we can contribute scientifically to our knowledge about double stars. You can measure them formally, you can submit your results, and that adds to our body of knowledge for double stars. It's very, very important from an astronomical and scientific point of view. That maybe some of your members view variable stars. It's equal in that respect. Variable star research and double star research can contribute in the same sorts of ways. Variable star research is well understood. Lots of people do it. It's pretty easy to do it. But what's the deal? Why aren't people doing the same sort of thing with double stars? I don't quite understand that. So you can tell I'm on a bit of a mission to get people doing the same sorts of things that lots of people do with variable stars. Who can do variable star research, or double star, research? Anybody. The professionals do it, scientists, researchers do it. If Karim is here, lots of teachers in high schools or colleges or universities get their students to, say on a weekend, measure a bunch of double stars and then prepare a paper and submit the paper and so on. That's very, very common that people are doing that around the world. So this means the great news is you and me, any of us with a half decent sort of telescope can do double star measurement, and we can contribute scientifically again to this. So that's great news. We can all do citizen science with double star measurement. I like this quote by Ron Tanguay. He's one of the authors of a few of the articles that I read in Sky and Telescope magazines over the years. And And he has a great line here. He says, because so few professional astronomers remain in the field, that qualified amateurs are badly needed. So that's kind of a request. They want us to look at double stars and measure them. It needs to be done. Why? Here's a bit of why. The official database, by the way, the official source or catalog for double stars is the Washington Double Star Database, or the WDS. This is owned by the U.S. Naval Observatory. Currently, the database is accessible and hosted at Georgia State University, so you can look this up. I gave Russell the links, so these can be shared out to you. So and you can see it. I've got it shown on the slide there. So if you can read that, astro.gsu.edu/WDS, that'll take you in there. But this is the official source of our data on double stars. And if you start looking at that, you'll see that there's immediately visible, there's over 150,000 records in that, and it's growing on a regular basis. If you go into that database and you start looking at it closely, you'll see that there's old data. Now, I don't know if you can see my numbers here clearly, but if I highlight that first row, you can see that that first double star entry was observed for the first time in 1991. It was observed again in 2010. So that's pretty current data, right? So that's pretty good. But the one that I've highlighted here, observed in 1930 and then observed in 1940. And if you go over to this column, the number 2, that's the number of observations total in the database. It's only been observed 2 times, and it's almost data that's 100 years old. So we need to look at that data. Somebody needs to go look at that double star. Now, if you find really old data and you go over to the note column and there's an X in there, that might mean you've got your work cut out for you, because sometimes the old double star entries, we can't find them. We don't know what double star they were talking about. The coordinates were wrong or something like that. So there's no X there. That to me looks like a good candidate. Go measure that. Go measure that double star. That's pretty cool. So you can examine the data yourself. You can download that stuff if you're good at putting imported data into an Excel file. You can easily build some filters and get a nice short list from that. And then that means you're on your way. You've got some good candidate stars to measure. And then what do you need in terms of equipment? Hopefully I'm not going to spend a lot of your money, but it's fairly cheap and fairly easy to get into this game. You don't need to spend thousands of dollars or tens of thousands of dollars. You can if you want. I don't care, but you don't need a big sophisticated scope. In fact, when I came to the Citizen Science episode number 3, I think, where Dominique was talking about measuring double stars and plate solving them with her very, nice, simple, basic rig, not a complex telescope, a nice little refractor on an equatorial mount. That's the kind of gear that anybody could use for this. So that's good news. John McHugh is an author. He's a teacher in the United Kingdom, and he has a great quote here. He says, observing 2 stars in a binary system is the only direct way we can measure the mass. And that information is core or central. It's critical for our study of stars, individual star formation, and open cluster formation. So this is really, really important. This is what you can add to our knowledge or understanding of double stars. So if you look at a pair of double stars and you look at them repeatedly, we need to keep going back every year, every couple of years. We need to keep looking at them. If you see 2 stars moving through space in the same way, at the same speed, in the same direction, we might ignore that because those are stars with high proper motion. But if you see one star moving in a curved line around the other, moving in an arc around the other, and you don't need the whole orbital period, you need a portion of the arc. If you can measure some of that arc, you can start to do all the other math to calculate the orbit. And when you can calculate the orbit, then you can determine the mass. And if you then combine that data with spectroscopic information, you can refine the distances, and that's important for our cosmic ladder. And this again contributes to our knowledge of stars and open clusters. Let me rephrase that. You don't have to calculate the orbits. You don't have to do spectroscopic analysis. You can if you want. But if you just get that data of where those two stars are to one another, and you keep sending in that data of where the stars are located in relation to one another, you are continuing our long, long legacy of studying double stars that goes back to the late 1700s. So again, you're contributing to this big body of knowledge. What do you need to do if you want to measure a double star? You need two pieces, or to collect two pieces of information. You need the separation, that's how far the stars are apart from one another in arc seconds against the celestial sphere. You need the position angle, and that's the angle from the north position to do that. You want to try it? Let's measure a double star. So let's say that this field of view that we know for an eyepiece, obviously it's a square, but let's say that this is a round field of view, and from top to bottom, let's say that that's a tenth of a degree. So your eyepiece shows a tenth of a degree, right? And if I'm doing my math right, if we multiply that by 60, then we get 6 arc minutes, right? 6 minutes of arc, and if we multiply by 60 again, we're getting 360 arc seconds. Okay, so our eyepiece shows 360 arc seconds. So I want you to look at that. There's the A star, there's the B star, that little faint blue star. How far apart do you think they are compared to the total width of your eyepiece? Type it into the chat, shout it out, unmute, shout your answer, mute. What do you think it is? So Karim says 120. Terry says about a quarter.
It may not be in the same plane.
So if I'm looking at it, it's roughly about a third, maybe a bit more than a third. But let's say it's about a third. Okay. So Karim got it. We take the 360, divide by 3, and we have 120 arc seconds. That's a very wide separation for double stars, but most are like 10, 20, 40, something like that. But that's a wide pair. So be it. What about position angle? How do we get that? We start with north. So here's north, aiming towards the north celestial pole, and we have to go towards east. Now, you know your telescope may present the field of view one way or another. It's either going to be clockwise or counterclockwise based on the number of reflections that are happening inside your telescope. So I'm assuming you're familiar with that. You know what's going on in there, and east is going to be clockwise or counterclockwise. In this example, we're going counterclockwise. So that would mean east is 90 degrees from that. So keep going. Tell me what the position angle is. What do you think? Shout it out or type it into the chat. Lots of people are saying 225. So if we go to the 180, it's about halfway along the way to the 270. So 225 sounds like the magic number to me. 225 degrees, 120 arc seconds separate. There, you just measured a double star. Done and dusted. You collect the usual other data, the date, the time, your seeing conditions, altitude, elevation. The elevation in the sky is important because there's the atmospheric refraction and stuff like that. So for high precision, you factor all that in. You keep track of the date and time, of course, because you want to know the declination of the star, and that figures into some of your math calculations and so on. But it's pretty easy to measure a double. This shows you can do it casually just by looking at it in the eyepiece if you know where north is. So that's pretty neat, pretty easy to do. We need to know. That's a bit more data that you're collecting than the variable star observer, admittedly. It's sort of twice as much work, but so be it. Now let me talk about some of the tools and the equipment that you might need to do this. In a perfect world, you would have an equatorial mount, and you've got tracking that you can pause. You need to magnify the view. For best results for high quality data, you need to increase the focal length to over 3 meters. So that might mean a Barlow or a Teleview PowerMate or something like that. And all the other stuff that you would normally use. You want good focus, blah, blah, blah. But now I'm going to talk about some specific methods here. And some of these are old. Filar, we can probably ignore that. If you have a Filar instrument, you should be donating it to a museum. These are the early original instruments that were used. They had movable lines in them, and the whole assembly could be rotated. The reticule eyepiece that I was talking about, here, we probably need to cross that off because you can't find them anymore. The manufacturers aren't making them anymore. Bader Planetarium, Celestron, and Meade have stopped making these. If you go to the Bader Planetarium website, though, you can fill out a form and say, I'm interested, I want to buy one if you start making them again. So if they have sufficient interest, they're going to do another run of them. Lots of people have a crosshair eyepiece, and I figured out the math. You can do it with a simple crosshair eyepiece, but there's a lot more trigonometric calculations that you need to do. So that may not be fun. I've started doing DSLR imaging. And I like imaging. Lots of us like imaging because you shoot the images and it's freezing and it's cold, or the mosquitoes are biting you. It's one or the other. So then the next day indoors, you can reduce all your data. We've seen that Dominique uses an astronomy camera. So you can use any kind of camera, including an EAA camera. So lots of people are doing imaging of double stars now. There's advanced techniques, which I won't go into, but lots of people do lucky imaging. I've heard about speckle imaging. I've read articles about it. It's black magic to me. I don't know how that works exactly. And you can also do armchair astronomy. You could use robotic telescopes, or you could study survey images and look at double stars that way. So lots of ways, lots of methods can be done, and that's not inclusive of a couple of other techniques. But those are sort of some of the really big popular methods that you can do. So again, I'm doing more and more. I'm doing just stuff with my simple telescope on my simple DSLR camera. You saw Dominique's method. She shoots the images and then she plate solves them. And she is able to determine the field size and the angle of the camera, and then infer all the other things that she wants to do. I kind of do a brute force method. I put all my images into the Reduc software by Florent Loss, and I put all my calibration images in. It calculates for me the angle of the camera and the field scale size. Then I put in my primary image, and it tells me what the angle, the position angle is, and what the separation is of the primary target. But then I also plate solve them to cross-check it, to corroborate the data. So you can use a bunch of different sort of methods here. Ed Hitchcock of the Toronto Centre many years ago wrote BinStar, but I don't know if that works anymore. That's an old application. But the new Astro Image J free software, it can do this analysis too. So there's lots of tools out there that you could use to help you do the number crunching and the data reduction. And if you're going to do science, there's a bunch of best practices. You should repeat your imaging here. Let's say you set up Friday night, you image a bunch of double stars, leave the rig alone. Don't touch it, don't move the camera. Cover it, then go out the next night and image the area again. Get more data. That's just a best practice. Repeat the imaging run to double check that you've got good information. That helps in your data reduction, reduces your data bar error, and so on. All the usual things, good log notes, stuff like that. I shot a bunch of images one time and I didn't keep good notes, and it took me hours to figure out which double star was which. So keep good notes. I usually use an audio recorder. And that helps you get good quality results as you're reducing the data. So let's say you've got now a bunch of measures and you go, I want to get this added into the Washington Double Star database. How do you do it? You need to write a scientific paper. Now that might scare a whole bunch of people off right away, but it's pretty easy to do. It's no more difficult than writing an essay in high school. It's a particular format. It's easy to learn the format. And then when you submit that, and I'll talk about the two popular places for submitting the result, then somebody will read your paper. They might give you some suggestions. So as they review it up here, they may note some errors or give some suggestions to you. So you apply those corrections, you submit your final, it gets added in, and then sooner or later, your data will get included in the Washington Double Star database with your name or code beside that. There's videos, books that can help you learn how to write a paper. I asked Karim if he might provide support or information to people that are trying to do that. You could reach out to me. You could look at the RASC journal. There's scientific papers published there. So it sounds intimidating, but it's not difficult to do. Here's where you submit your data. You can do it to a North American clearinghouse or one in the UK. I've submitted to the Journal of Double Star Observations, or the JDSO. That's another thing to do. Go to these websites and look at the papers that are there. Again, that shows you what people are doing and how they do it, and you'll see all the students that do results and analysis. So it's pretty great. And then again, once you've submitted your data and it's been vetted, your data will appear in the Washington Double Star database. So boom, you've added missing information into the WDS. And we saw that there's lots of old data in there. When can you do this? Anywhere, anytime. We know that double stars are pretty resilient to light pollution, so you can do it in your backyard. That's kind of cool. Any clear night, ideally you want half decent seeing, but I don't wait around for that. I just do it when I can. So it's pretty easy to do. Boatload of websites here, but Russell is sharing those. Thank you. Stellar.Doppy, some people use regularly for double star data, and I just want to point out that it's not the official source, but they pull the data out of the WDS. I like using Stellar.Doppy though because it's easy. It's a nice interface. You can pull up the orbital diagrams for star. You can look at the historical entries for double stars. So WDS and Stellar.Doppy work really well together, but all the data for Stellar.Doppy is coming from the WDS. Sky and Telescope is a big fan of double stars, so lots and lots of articles that are there. Bruce McAvoy has this amazing website. It's absolutely incredible on double stars. He even talks about how to train your eye how to look at double stars. Really, really good stuff there. There's lots of fans in the Cloudy Nights website, and a bit of shameless promotion. You can go into my blog and use the keyword or the tag search double stars, and you'll find lots of information there. I mentioned the JDSO and the web, so look at those for more information. Look at the RASC journal on various papers, but you won't find a lot on double stars. Again, go to the Sky and Telescope websites. You might read the old February 1999, July 2000 website or articles on how to measure double stars, except they're done with astrometric eyepieces. One of the best books on, and it's a bit technical, on observing and measuring double stars is by Robert Argyle, but make sure you get the second edition. While it's not perfect, it's better than the first edition. And if you're curious about how to rate double stars and you want to see a very enthusiastic person, Jolyon is a teacher or an instructor, and he has students that he regularly encourages to measure double stars, and he's got lots of fun videos, and he even has videos about how to rate a paper. We had Dr. Katie Breivik speak at the David Dunlap Observatory, and I had a chance after I read her white paper on stellar multiplicity to ask her a question. I said, can citizen scientists contribute to our knowledge and understanding of binary stars and multi-star systems? And she almost fell out of her chair. She said, absolutely. She was grateful by the contributions of amateurs, and she echoed what we heard earlier. We don't have enough long-term data. So we need more data to get more understanding about how binary stars work. So that's really good. So we can all contribute. We can all do citizen science and measure double stars. You can be a citizen scientist, and it's pretty easy to measure them, and it's pretty easy to write up your results and then submit those for review, and then you've got some data included in the Washington Double Star database. And I didn't say it anywhere along the way, but there are discovery opportunities. So you might find a double star that nobody else has found. And I hazard to guess there's a lot out there. So that's cool. Your 3-letter code can get attached. You know, RF1, Russell, might be a brand new double star that you have found that nobody else has seen. So anybody can do this, and there's a potential for discovery. So thanks for your time. Merci beaucoup, Miigwech. Thanks for letting me talk about my double star addiction.
Thanks very much, Blake. That's a great addiction. Boy, oh boy, that's really nice. So I guess I put all the links in as you gave a
Thanks a
talk.
lot.
So that'll be in the, and Kareem had a great idea. So I think we'll put this in the next edition of our Skyward newsletter as well. So that'll be good. And if you have any questions out here, lots of good feedback. Thank you, Blake. Terrific talk, excellent, etc. I certainly agree. So we'll wait for some questions, but of course, you already know what my first question is, Blake. So where do I find this list of relatively short period doubles that we can measure over a few years?
Is there a way that we can easily cull that information out of the Washington Double Star database?
Okay, that's better.
Or Stelladopy? I don't know if there's an easy way to do it in those tools. Unfortunately, it's a lot of data mining and digging.
So there's no period in that table that you were showing us?
They do show it, especially in Stelladopy. You can see the period, but lots of double stars are not binaries. So if you go into Stelladopy, you'll see that there's a pair and it's unknown, or it's a proper motion pair. So you got to look for the ones that are designated as a binary and they have a preliminary or a definite orbit. But it's just fiddly how you have to do that. It's a hierarchical database, so it would just take a lot of effort to mine
We
it.
just can we cut and paste it and put it in Excel and then sort on the value?
Yeah, again, not really easy. But what I do is I pull that data out of another tool. I use SkyTools, the SkyTools planning software.
Yeah.
And the SkyTools planning software has a checkbox where I can say, show me binaries. And then it's got a box where I can indicate the period. So I put in maximum of 100 years. So I use SkyTools. That's how I built my initial list. So anybody that has SkyTools, they could do that. You just do the kind of an advanced search. This assumes you have SkyTools Pro, and you can do an advanced search and get a nice list there. And I always offer to people, since I use the SkyTools software, if you want that list and you can't find it anywhere, let me know and I can generate a list for you.
Sure, that'd be great. All right, thanks.
I have about sort of a short list of about 24, and I put them in my calendar. So at the beginning of every month, I have a little reminder of go look at this binary, go look at this binary.
Okay. And you've picked up on a few that have actually changed position angle or separation?
There's a few where I can tell they're moving, but I've been clouded out for a lot of these. So I've really only begun a serious campaign in the last couple of years. But I'm just trying to get better at my note taking. And for some of them, I'm starting to image them. So every year I image it. So 70 Ophiuchi, for example, I've been imaging that. I've got 5 or 6 years of data now.
Ooh, nice.
But I'm going to make a little animated movie with each one of the frames, right? And we should be able to see the star moving a little bit.
That's cool.
I haven't made the movie yet.
Okay, cool, thanks. Yeah, that's a good idea. So is it better to image rather than do visual?
I love it all.
Yeah.
I have a foot in both camps. I love visually looking at double stars. That's what I often do in my backyard. I get goosebumps off of that. The doing imaging, that's a big production, right? It's a lot of work. So I want not one but a few clear nights in a row, and then I haul out all the extra gear to do that.
Okay.
And sometimes I do campaigns. I'll look for an old double star, say 100 or 200 years old in the database, and then I'll go measure that one, and I'll start imaging it and see if I can do that. So when I want high quality scientific results, I'm trying to image them.
Okay, yeah, because I tried that. So I read the book that I guess this one, and so I tried it with beta. Was it monocerat? I don't know how to say it.
Yeah.
That one. And,
Yeah.
and visually, I found it was really pretty. And then I
Yeah.
imaged it with my DSLR and went, okay, yeah, it looked less pretty, but I guess I kind of have a permanent record of all their positions.
Yeah. A neat trick to do when you want to image a double star or a multi-star system, and get the really sort of fun, wow, picturesque look to it, is to do high dynamic range. So shoot a long exposure so you get all the field stars.
Yep.
But that will blow out the A and the B star. They'll be super bright. But then do another better exposure where the A and B or the bright stars aren't blown out. And if you're good at assembling things in software, layering and stuff, say in Photoshop, you can produce a high dynamic range image where you got nice field stars and you got this beautiful double star system.
Good idea. All right, thanks. I will try that.
For measurement, I do the shortest exposure I can where I can see the primary objective stars, where I can see the A and the B, for measurement. And I don't want flat top stars. So you got to be careful to get the exposure down so you're getting nice, not overexposed bloated stars. That may also be important if you have a faint secondary near to a bright primary. If you overexpose the bright one, you'll lose sight of the secondary one. Hey, Carl.
David has a question.
I have Carl a bit of information about Carl, or for Carl here. Just a week ago, I finally saw Sirius B. I've been trying for years. I finally got it.
Would you like to receive the Sirius certificate from our center?
Oh no, that's very kind of you. I'm quite satisfied with my personal accomplishment. Thanks for offering, but I wanted you to know that I did it. Woohoo!
But it's nice to have, if we could have a certificate for somebody, because you're a member of the society, so we can present you the Sirius certificate, just because you're a member.
Well, we'll talk about that. Okay.
Okay. Maybe we could, keep it. Yeah.
Yeah.
You might even be able to get the gold certificate because you have 1,700 stars. So maybe it's in our 300 program.
Yeah, maybe I got some of them.
Probably. Okay, David, you got your hand up. Very patient.
Well, thank you so much, Russell. And Blake, I really did enjoy this. I'm sorry I got in a little bit late, but I really did enjoy it. And it brought me back to the happy days of the Montreal Center. The person that got me interested in double stars was Carl Jorgensen. Carl has had a lifelong fascination with doubles. He introduced me to my very favorite double star. That's a weird name, Sigma 2816 Cepheid. But it is a weird name, but it's easy to find. It's pretty close to Mu Cepheid. And it's actually a lovely triple star, extremely easy to separate. And if that's not enough for you, just about half a degree away from it is a double star, Sigma 2819. And while I've got you, I do have a quotation for the meeting tonight that I'd like to share with you. And it wasn't about double stars, although I think the star cluster that I'm about to talk about briefly has many, many double stars in it. This is the star cluster Omega Centauri. And I like to imagine William Shakespeare. He's just finished writing Julius Caesar, and he's finished, he's exhausted. So he goes outside, sets up his telescope, and he looks at Omega Centauri, and he writes these words: "This is the noblest star cluster of them all. All the star clusters, save only he, did what they did in envy of great Caesar, of this great star cluster. He only, in a general honest thought and common good to all, made one of them. His life was gentle, and the elements so mixed in nature that nature might stand up and say to all the world, this is a star cluster." Wonderful, wonderful talk, Blake. Thank you.
Thank you very much.
Yeah, thanks to another great quote.
Hmm.
Other questions, comments? We put the links in the chat for you if you're interested in more. We'll also put it in the next edition of Skyward. I'll talk to Gerald about that later. And I don't know, I'm looking forward to it. I guess the next clear night around here in Montreal will be next sometime towards the end of next week.
Remember, you need medium to great seeing, but transparency doesn't matter. If it's a bit hazy, that doesn't affect double stars. If the moon's out, doesn't matter. Look at double stars.
Thanks.
You've got my email there too, so if anybody has questions after, don't hesitate to reach out.
Great, awesome, great. Thank you very much, Blake. That was really, really great.
Thank you
Very
again.
good. So now we're going to continue. I've got, let's see what I got here. I've got our little, oh, I cannot share the screen. Okay, I can't share the screen. All right, but our next speaker is our own member from downtown, Quatran, a deep sky from downtown. So Qua's been really wowing us with his really impressive astro images taken right from his apartment in downtown Montreal. And we asked him to share his experiences and his secrets, the secret to your success, Qua, especially that one about the supernova. How did you
Oh,
do?
yeah.
Oh, that was great.
That was blind luck and a little bit of an assist from Karim, I think.
Okay, so it's
Yeah.
all yours.
Thank you very much, Russell, and thanks for inviting me, and thanks to Blake for that lovely talk. I want an astrometric eyepiece now, and I'm going to share. I think I'm going to try to share content screen. Page commence.
So did Paul give you the permission to share? Yep. you
Okay.
did. Okay, good.
Excellent. And now, does everyone see me, or does everyone see my first?
Yes, we see it.
Excellent. Is that the Star Wars color and font? Oh no. Oh, okay. Anyhow, it's not going to, there's no title call. It's going to be all right. So thank you very much, Russell, for the introduction. Hello, everyone. My name is Qua. I have not yet been able to split Sirius myself visually. That is also on my bucket list. I've tried and haven't yet been successful. I've been a member of the Montreal Center for a number of years now. I think between bad weather and pandemic, if anyone even recalls what a member's observing night was like at this point, you might remember me as that guy who shows up on a motorcycle with a tiny telescope and then uses this telescope to find faint fuzzy objects with some ease some of the time. And the reason that I can do this is that I get a whole lot of practice from home here in the plateau, where the skies are about as bad can be. So to put things into perspective, I'm near Laurier Metro Station, and I did a quick calculation on Google Maps, and I'm within 3 kilometers, just over 3 kilometers of that lovely Place Ville-Marie rotating spotlight beacon that illuminates half my sky on a given night. So from there, from my balcony, I estimate that our limiting visual magnitude is 3 point something, because I lose one of the Big Dipper stars in the wintertime when the snow reflects the light pollution back up into the sky. And the Keystone in Hercules is a lot harder than I'd like to admit to being able to pick out sometimes. So I've always suspected that our skies are really bad because Montreal is the second largest city in Canada, but I didn't have any numbers and I didn't know how bad it was. So I did a little exercise recently where I compared our sky quality with that of some other famously light polluted places with data from clearoutside.com. And I think Clear Outside uses data in turn from places like lightpollutionmap.info and other sources. So the first screenshot is for downtown Montreal, right in front of Marie-Reine-sur-Monde Cathedral. And the second is basically, it's my metro station, Laurier. So if you look at that, you know, we're over, 10 millicandela per meter square. And if you look at, Toronto, which may be a larger city, but our skies are somehow worse. And I don't know whether to feel proud of this or ashamed of this, really. You remember the famous Shibuya Scramble crosswalk in Tokyo. We're somehow also worse than that. I was born in Hong Kong, and Montreal's light pollution is somehow worse than that of the Mongkok commercial district in Kowloon. Ditto for the Eiffel Tower in the so-called City of Lights. So let's feel a little bit better about ourselves here. What's a place with worse light pollution than us? There you go. You know, Rockefeller Plaza beats us handily. So why, pray tell, shoot deep sky from downtown? So I live in the city without a car, and we're raising a toddler whom you may or may not be able to hear screaming as she's fighting going down for bed tonight. She was born just a couple of months before the first of the pandemic lockdowns. So suffice it to say that I've been spending a lot of time at home. But we're also lucky enough to have, access to a rooftop balcony above most street lights and with a clear view of Zenith. And because trips, consequently, trips to darker sky sites are precious commodity. And astrophotography is really kind of a long game. It's like a Japanese RPG where there's, a heavy experience point grind involved. So it's better to learn and to make mistakes at home first, rather than making them after having rented a car and driven, an hour or two out to a dark sky location where, you're trying out a new technique or you're trying out a new piece of equipment. And you're basically bringing an untested army into a faraway battlefield. And to be blunt, this kind of shooting really isn't for everyone. Like the images I take can't compete with stuff you take in dark sky sites, especially the stuff with that's taken with a lot more sophisticated equipment and by people with a lot more experience than I do. But even though I'm not going to make astronomy photo of the day, it could still be really rewarding and a lot of fun to do. So to deal with all of this light pollution, you have to pick your targets, use filters where appropriate, and there's no real magic to it. Unfortunately, you just have to gather lots and lots and lots and lots and lots and lots of data to take advantage of modern stacking in image processing techniques. So when we're out in darker skies, we do our best to avoid the light domes of cities. But when you're living inside of one, you can still benefit from waiting for a target to climb high enough in the sky to reduce the impact of light pollution gradients, to give yourself a fighting chance to be able to reduce or eliminate that in post-processing. And filters can be helpful, but they're not magic. I see on more beginner astrophotography forums, people talking about how, they get their first light pollution filter, their first nebula filter, and they think that it's magic, but really they can only block light. And unless you're specifically imaging in narrowband, any light that you do block from a broadband signal is necessarily taking away, from the target itself. So again, we're aiming to build as strong a signal to noise ratio as possible. I figured I probably should have done a bit more math and included it here, but I'll blame it on the last minute nature of my prep here. So in the city, sky glow noise is the main beast we're trying to slay, and stacking will increase the SNR to the point where we can do our best to stretch and lift the signal up from the new noise floor that we define. So for example, this is a single 2-minute frame of the Rosette Nebula from my balcony. If you squint really hard, you might be able to imagine the rose petal nebula structure around the central open cluster there. And this is 30 frames. You need less imagination to be able to see it, and 150 frames. And finally, 412 frames. It's actually hard to see here, I think, in a Zoom presentation, but you'll have to take my word that between the magic point really was somewhere between 150 and 412, because every night that I went out and gathered data, you can get a feel for just how the data reacts to your stretching and your manipulations. And after a certain point, I think it was 8 hours worth of data from my balcony, it was like, wow, this is holding up well. It's not falling apart to pieces if I so much as breathe on it. So at 412 by 120 seconds, 2 minutes, we're getting very near 14 hours of total exposure time here. And I think I'll share the final edit a little bit later on in this presentation. And so talking a little bit about equipment, astrophotography can be really expensive. And for the time being, I'm still on the budget end of things. But you start adding up the cost of your camera, your imaging scope, your guiding, your mount, and it's like it becomes a serious bit of equipment. Even though really I really am still on the lower end of things here. So I've just got a normal mirrorless camera, short refractors, and a camera tracker, and this limits me to wider fields, less demanding image resolutions, and shorter exposure times. But in the city, the latter really isn't necessarily a bad thing, because sky glow and airplanes and now satellites, a ruined 1 or 2 minute frame is way less painful than ruining a 10-minute frame. So I've dabbled in a number of things over the years, from building my own hand crank barn door tracker to hacking a Celestron motor drive onto a small Explore First Light EQ mount, and now to trying to push a Star Adventurer to carry a refractor and auto guiding. So my main criterion, because these dark sky trips are precious commodity, is that I have to be able to break it down and carry everything in one trip on foot to a Communoto parking lot 400 meters away. And a nice to have, of course, as well, is an unguided subset that I could break down and throw onto my motorcycle. So here are some setups that I've tried over the years. On the left is my homemade barn door tracker. That's a 40 to 150 micro four thirds lens that's on there. It's pretty hefty, actually. And I was able to carry that telephoto lens and track with pretty good accuracy up to about a minute or so, because I started using a cardboard tick wheel with second gradations. And I would have a metronome in an earphone in my ear, counting out 60 beats per minute in 5/4 time. But you can imagine that a camera with that long of a lens on a barn door is an unbalanced load, and adjusting your framing with any kind of precision becomes really difficult with that ball head that's on top there. And also it's intensely hands-on. And if the whole time you're listening to a metronome, tick out, ticks, and you're just trying to turn to match that ticking, it becomes a little boring. And you're out in a dark sky site or wherever you are, and instead of looking up at the sky, you're looking at a little wheel in your hands. So the middle the middle photo contains a monstrosity that I was running through most of 2020. It's actually you see the progression stacked in layers. So you've got a Celestron motor drive with the covers off, running, trying to drive an Explore First Light EQ drive, and it worked. But pretty soon I gave up on that, and you see here it's just acting as a glorified latitude wedge for the Star Adventurer Mini, which has no business carrying that 60mm f5 vintage 1970s TOA refractor, Acromat refractor, which in turn has no business being used for any kind of imaging, because I'm putting a field flattener I stole from another telescope, and you know, this whole rig was held together, I kid you not, by poster putty and JB Weld epoxy. And finally, on the right is more or less what I'm running today. It's just an off-the-shelf Star Adventurer with a standalone auto guider, and I'm running an Evo Guide 50 guide scope that has a couple of ED lenses, or has one ED lens in it, and it can pull service as a decent wide field imager if you've got a field flattener in it. And here is my iCybe robot dog, wondering whether pressing an Orion ST80 into service for galaxy season out of desperation is really a good idea. Okay, on to some images. So the Veil Nebula is something that I've really only been able to see visually in, like, my biggest telescopes that I own are 4 inches. I've got nothing big. And with a 4-inch telescope, I can really only make it out in decently dark skies. But here it is in its mostly full glory from my Bortle 9 balcony. And here's the famous flame and horsehead combo off of the easternmost of Orion's belt stars. And this is kind of what I mean about filters not being magic. I've got like seven hours or so of data here. And because they can only take away light, you know, they made my life a lot easier for being able to pull out, you know, the signal that's let through by the filter. But like, you can, if you compare it to, you know, images that other people take from darker sites, there's a lot of the blue reflection component that's missing, and once you see it, like, you can't unsee it, or I guess in this case, once you unsee it, you can't help but see it again. But all that being said, if someone had told me just a few years ago that I'd be able to take this image from my balcony in the middle of the city, I would never have believed it. Like, the Flame Nebula, I have seen once in my life through my 4-inch telescope, and that was a couple of years back while we were camping at Montméantic. And there it is, just, you know, in the middle of down, like, the plateau in Montreal. It's bright as anything. And here's the edited image of the Rosette Nebula I showed earlier. So the cloud slightly, I don't know if it's been like this, if it's like this every year, or is it just because of you know, this weird reality we've been living in the last couple of years, where we feel like, has it always been this cloudy in this part of the world? But this past January, there were 6 entire clear nights that weren't next to a full moon. And this image contains data from all 6 of those nights. I never intended it for it to be a month-long project, but there you go. And this is the same image presented in a simulated hydrogen, oxygen, false color palette, or pseudo HOO. It certainly gives a different look and contrast using the same data. And it's a technique I've been playing with lately, even though, you know, technically speaking, you know, the UHCS filter isn't a bona fide narrowband filter, so you can't really call it HOO, but you know, it kind of gets the idea across. And speaking of full moon nights, I shot the Orion Nebula last month on the ST80 over 2 nights, you know, one on either side of the full moon. And now full moon nights aren't great for, you know, quote unquote, if you want to call them serious imaging, but they're really a really good time to try out new equipment and new techniques, because it's kind of like a low consequence night. So often I'll shoot open star clusters and star fields just to get a handle on how my guiding is working, if I wanted to try a new filter position, or if I wanted to try a new telescope in this case. So this is mostly to test to see how the ST80 would hold up on a small star tracker like the Star Adventurer with guiding. But I actually like the results enough that I combined it with some unfiltered data I got from the Evo Guide out in Hudson one night. So this is deep sky from downtown, although, you know, admittedly with a tiny little bit of cheating. And here is the famous Andromeda Galaxy needs no introduction. This was one of my first serious attempts at auto guiding last fall. And before that, I'd be taking, you know, 30-second images unguided, because any more than that, and you'd start to see trailing in right ascension due to the mount's rather large periodic error. So, but in this case, moving to auto guiding, I'm like, I can, rather than stacking 522 30-second frames, I can take 87 3-minute ones, and that makes my antiquated 2015 MacBook a lot happier. So Russell mentioned this a little in his introduction, but did you know that I almost accidentally kind of discovered a supernova a few weeks ago? Thanks to a tip from Karim, I realized that I'd caught a supernova in a wide field test shot I took of the other Leo triplet, so M95, 96, and 105. So one of the bonus galaxies in the frame is NGC 3367, where the supernova was first observed on March 19th. So for a hot minute, we wondered whether I was early enough for accidental co-discovery credit, but alas, I was a whole 4 days late. But you see here, like that's an eye blink in the scale of the more than 120 million years the light from that exploding star has taken to reach us, and it was really an exhilarating, incredibly exhilarating, incredibly nerdy experience, staying up late to zoom and enhance, and then invert the image. I'm at 2.6 arc seconds per pixel here, so I'm not. That's not a very high resolution at all. So I don't know how clearly you can see it here, but zoomed and enhanced and inverted, it's the supernova is a couple of pixels across in diameter, but it's there, and I accidentally caught it, and I think that's pretty cool. So I've just got a couple of slides left. So shooting deep sky from downtown isn't necessarily for everyone. The targets are hard to find because you don't have your reference stars, and star hopping, which is what I do, is a little bit more difficult. You have to plan your hops more carefully and pre-plan everything in advance. But I just wanted to show that you don't necessarily need specialist equipment to shoot it either. You don't need a star tracker. You don't need an EQ mount. So a few years back, I experimented with just a static camera on tripod. So no tracker, just finding a shutter speed that was just fast enough to avoid incredibly visible star trailing, and then firing away hundreds upon hundreds of photos, stopping every so often to reframe your target, and you're at that point you're letting your stacking software, such as I use Cyril, to load these hundreds and hundreds of frames, and you're letting the stacking software do the heavy lifting in registering, so taking care of the translation and also the rotation between frames, and then stack everything for me. So what you see here, it's barely on each target, it's just a few minutes worth of integration time, and I really didn't know what I was doing then. But it just goes to show, this is just a telephoto lens with a normal camera on a static tripod, and when I took this, these are objectively not fantastic images, but the feeling you get realizing that the stuff that you only thought you could see out in dark sky sites, you can image, you can capture them no matter where you are, more or less. So to sum things up, again, shooting deep sky from downtown isn't easy. It's often not pretty, but it can be very rewarding. And if nothing else, it's great practice to prep for dark sky trips. And finally, it's a humbling and reassuring feeling to know that beneath the veil of light pollution that we see fit to throw up into the sky, that, like I said, our favorite objects, our favorite deep sky objects, are still there. They've always been there. They were there long before we mastered the use of artificial light, and they will continue to be there long after those lights will have faded away. So that's all I got. Thank you very much for your time. Thanks, Russell, for inviting me, and I hope to see you all again in person at an observing night sometime soon, if those things ever happen again, if our skies ever clear up. Merci bien. Thank you very much.
Thank you, Kwa. That's great. That's all you got. That's a lot. Wow, that's super impressive. I really like that supernova picture. That's very cool. Yeah, I mean, the first time I saw you when we went out, I think once to
The one observing night we had last year.
last year, that's right, over at Morgan Arboretum, and then you showed up in the middle of the darkness on a
I
motorcycle.
had that orange telescope, that little orange. Yeah.
That's it. That was like cool. I was like, how did you get all that stuff on your motorcycle? Wow, I was very impressed. Oh, nice guitars too. So I don't know if you've been looking at the chat, but you got lots of great feedback. Well done, beautiful images. Thanks, amazing, great presentation, great images, and nice.
Thanks, everyone.
You know what blows me away the most, though? Because I've asked you this before. Your camera's not even modified.
No, I think I just got lucky, honestly.
Yeah.
I just got lucky that the camera that I shoot with in daytime happens to be, sensitive to hydrogen alpha.
Yeah.
Yeah, it seems like it.
Questions, anybody? You can raise your hand or put the little hand logo up or just speak up.
I'm finally seeing the chats now coming up, and Gerald saying, "Remember the crash of the shuttle scope?" There it is.
There
it survived. It survived. The greatest telescope ever made.
At least the most memorable. Well, Blake has a question. His hand's up. Blake, you got the floor.
I just typed into the chat, but what's next? Do you have some plans about a different sort of platform, or are you going to try some different filters?
I don't know right now, because
you said you're on a budget, so
yeah,
I'm not trying to spend your money, but just curious what you're thinking.
I thought I was going to get an astrometric eyepiece and start measuring double stars. No,
save your money for that. Yeah.
No, but I don't know. Because I'm on my rooftop deck, it's not the most stable of platforms, and I do have kind of fantasies of being able to pack up everything and take it out to a darker sky site. So my limiting factor right now really is the mount. And that's the thing about, these modular systems, that it's kind of like building Lego pieces. You can swap out, bits a little bit at a time. So where should I start? Do I want a slightly bigger, ED scope like Russell has, and like an ED80? But then I need a bigger mount to carry that, and then I need, a steadier deck, or like a better tripod. It's just in the short term, I'm trying out the ST80, the short tube 80. It was never meant to do astrophotography. I've been spending the past few days, plugging up light leaks like crazy on that thing, because it was just never meant to do that. But it's fun, and you try new things, and it's galaxy season. It's the coolest of all seasons for guys without long focal length scopes or large aperture scopes. But I'm waiting for the summer nebula season to come around again. And honestly, it'll be fun, instead of imaging on the balcony, even just to be out at an observing night and looking with through an eyepiece, because it's certainly not as fun to look through an eyepiece here.
You know what? It's coming.
Yeah.
I promise. Sometime
Okay.
we're gonna have our Starbecue. We're gonna have everything. We're gonna take back what we were robbed of for the past 3 years.
So I guess, Blake, do you have any suggestions for me? What you think I should try next?
Well, I don't know. It's very impressive, your rig, and it goes to show, a lot of people get in this hobby and they think they have to spend thousands of dollars to get a decent image. And what you're showing is, start simple. Don't spend a lot of money. And it's, to me, it's like a lot of things. Somebody wants to take up tennis, and they buy a $600 racket, and they don't know if they like the game or not.
Yeah.
So, save your money.
Sure.
Get simple equipment, build the skills, do the skills first, and then you'll be able to then do amazing things when you get a nice windfall or you do a nice upgrade. But it's very impressive what you're doing, and I always like that approach. Run what you brung.
Yep. Thank you very much. I really appreciate that. I totally agree.
You give me encouragement that on my balcony here in Côte St. Luc, which is, like you say, it's so light polluted, I have trouble seeing parts of the Dipper. Well, I'm on the south side of my building, so I can't see the Dipper at all. But now with the new ASI Plus, I can do polar alignment without the pole.
Yeah. Okay.
So for me, that's a big deal. So maybe I'll start to be able to get more data or images like you're doing from my balcony at least. And I can even string through the tablet is Wi-Fi, and you know, like, so I'm excited because it shows that it is possible to have something developed or come out
For sure.
from deep into the city.
It might take 14 hours for it to come out, comme il faut, but like.
True. Those are long exposures. Wow.
Oh man.
What software do you use to assemble all that?
I use, so for the Rosette, for example, so I don't use anything to, because I have fantasies of being able to transport everything, you know, out to, you know, our dark sky sites or whatever, right? Like my personal rules are, like, I'm going to stay away from the dedicated astronomy cameras. I'm going to stay away from the PhDs of the world for now, just because, you know, like that adds layers of complexity, and I might not be able to fit it all in one trip. You know, then I have to go to the parking lot, bring the car back, bring everything down, and all of a sudden, you know, yeah. So with all that in mind, like with all that said, so I just shoot with you know, the intervalometer that's built into the star tracker, or the camera's built-in intervalometer. And when the frames are you know, taken out and put into my computer, I use Cyril to do the stacking. And then afterwards, I almost will always these days use StarNet V2, especially with emission nebula images, to separate the nebula from the star, like the star background, so you can stretch the two of them without things getting out of hand.
So the stars don't get bloated or just
exactly. Yeah. And then it's a lot easier too, like for things like if you've ever had flat frames where your dust motes will move around throughout the night, you think, oh, I'm done. But you know, you could cheat a little bit with, if you're using StarNet, because all of a sudden your background, your nebula background is something you can start, you know, using the heel brush on if you weren't too concerned about data integrity, scientific integrity there. No, stuff like that. Like it just makes life a lot easier. And then I finish off using GIMP.
Your horse head's gorgeous.
Yeah,
Oh,
really-
thank you. That's very kind.
Yeah, it's when I had my Alpha 7S from Sony, it was that ultra sensitive. Unfortunately, I had it stolen.
Oh no.
Yeah, it's cellophane, to be honest. In just 3 weeks before the eclipse.
Oh,
and
it's terrible.
And that camera, within one shot, I started to see the flame with the colors and the horse head with no modifications. It was a backlit sensor, and it actually came out. So excited that the year after I was going to start without modifying the camera to take like a lot of stacking, and then unfortunately got that camera stolen. I know Alex bought that same model that I had secondhand just a few weeks ago. So he's going to probably play around with that. It's a very sensitive camera. But I'm happy with my Alpha 6300 right now, my mirrorless.
That's cool.
Yeah, just in time for the eclipse though. I was lucky the insurance came through. So
yeah, and knock on wood for the eclipse coming up in a couple of years too.
Yeah.
We got a question from, oh yes, horse's head is so gorgeous. That's great out of context. And Russell's question about I use a standalone auto guider. It's a Skywatcher SynGuider 2. So I have a guide scope with a prism diagonal on it, and then I stick the standalone auto guider on top. Okay. It's not the easiest thing to use, and it's hard to diagnose when things go wrong. But it's all self-contained, and once you get the hang of it, and it works really well.
I had the Next guider from Celestron,
Mhm.
exactly the same. I recognized mine was like black instead of silver.
Yep.
But it's literally the same thing. There was a version where the chip was a little more sensitive.
Yeah, I have that one now. Yeah.
That's the one I got,
Yeah.
but then I was so frustrated with the way I had to set it up all the time with the XY and then, you know, all this stuff. And it was sometimes not sensitive enough for certain things. So, you know, I've done the ZWO way right now, which I still haven't used yet because of COVID, but wow.
Yeah, that is definitely the way that most people go. It's the most popular way. I'm bucking the trend because, you know, like I said, I still have fantasies of being able to put everything into a backpack. And
it's also pricey. I mean, once you start with the ASI Air Plus and this and a guide scope and a, you know, the guide camera, it starts to be like $1,000. Like, you know, when now it is an expensive hobby, as we all know. So
yeah. All right.
Other questions? Imaging if Qua is the first image dark matter from downtown. Okay,
or gravitational lensing and dark matter from downtown.
Yeah,
I thought about trying to get the integrated flux nebula from downtown.
Oh boy.
But you know, that's that's
already doing 14 hours. That's like 100-hour exposure. Right?
That's a lot.
Something easy, white holes.
Oh, I did get Hubble's variable nebula. I do have a picture of that. I don't have it on my iPad right now, but I did get it. Yeah, it's pretty bright. It's actually pretty bright. It looks like a comet. It looks like a comet.
Okay.
Yeah. Sorry, David, I cut you off there.
No, I say we should photograph white holes instead of dark matter and black holes. White holes. There you go. They're all over. Plasma marine, right?
Yeah. Man, yeah, that rotating, like you all know about that rotating spotlight, right?
What's a pulsar?
Yeah, that's it. It emits mercury wavelengths. Yeah.
Cool. Oh, Santiago has a good proposal for you in the chat. Einstein cross in Vegas.
Seems to me that spotlight on Bill Murray was made for Zeppelin landing and passenger embarkation.
Wow.
Cool.
Yeah.
All right, everyone.
I'm glad that worked out.
All right, well, if there's no more questions, thanks. Amazing, more inspiration. We've been inspired by Blake and Qua. It's really been great. This is we're coming to the end of episode 5 of our Citizen Science. And look, if you're interested in contributing, you can email me at outreach@rascmontreal.org. I'll put that in the chat as well. Otherwise, glad to see everybody on a rainy Wednesday evening, and hope to see you again soon.